What would you do to start solving this one? Add over the 4. You guys have been solving equations for a long time. You know how to solve, all right? The trig is the drawing the triangles, which again, my pep talk is the same as it's always been. There are only 4 quadrants, and there are only 3 sides it can be: a half, square root of 2 over 2, or square root of 3 over 2. Your choices are really limited. If you needed to guess, you got a good shot. All right, one more step though to get secant by itself, which would be what? Yeah, square root. Now, when you put the square root, you have to put plus and minus, and the square root of 4 is 2. Oh, and actually, we have one more step there. 2 is not on the unit circle, but 1/2 is. We need to reciprocate. So what is the reciprocal of secant? It's cosine. Good. So cosine equals plus and minus 1/2. And then we're like, okay, cool. That's on the unit circle. Go ahead.
It's like show that.
No, that's the step. That's it. All right. So what quadrants are we in? Well, since it's plus and minus, all of them. So it looks like a little bow tie. And I can't really fit this in here because it's really small. The cosine would be the x value. So just watch me point to this. I'll talk you through it. The 1/2 would go here, but it's so small, I'm not going to be able to fit it. But that's okay as long as we get the other side. That means this side would be square root of 3 over 2. And here's the whole point of the thing. What is your angle across from square root of 3 over 2? Yeah, pi over 3. And so when you list out your answers, there's going to be 4 of them. You're going to go around the circle and do all of the thirds. So the first one's pi over 3. What is the one in the second quadrant? Like, what's the next one? Yeah, 2 pi over 3. And then we've got 4 pi over 3, 5 pi over 3. So those are all of your answers. I'll zoom in a little bit because I am writing small to make it fit. So make that a little bit better. All right, onwards. What would you do to start solving the next? That's always my first question to the whole thing. What are you going to do first? All right, now you guys are advanced enough. We can do both steps at the same time. You would -1, subtract 1, so it's -1, and then divide by 2. Cool. So cosine of, and if you want to give that a hug, you can. Sometimes I like to put parentheses around that. It will equal -1/2. So we need to find quadrants where cosine is negative. Cosine is the x coordinate, so you'd have to go to the left. So what quadrant are we in? Yeah, 2 and 3. So it looks like half of a like butterfly wing here. Again, I'm just going to kind of talk you through this because you have to draw these sort of small to make it fit. Again, on the test, I'll give you plenty of room. But the -1/2 would go here. That's the x part of it. That means this side, square root of 3 over 2. And again, that means your angle is pi over 3. Now for this one, it's not just x. This tells you how far you go around the circle or how many times you go around the circle. We are going how far? We're only going halfway. So if you only go halfway around the circle, you don't make it there. So you're only going to get one answer. You're only going halfway around. So we get x over 2 equals 2 pi over 3, perfect. And then you have one extra step to get the x by itself, which is that we're going to multiply these both by 2 to cancel out that 2 in the denominator. So it'll be x equals 4 pi over 3, and that's the only answer we get. So if it's an x over 2 or like a half x, you only go halfway around the circle. Number 19 is arguably the hardest question on the whole thing because before we even start, what do you notice about that one? Well, there's a square root that makes it tough, but also, so we are going to go 3 times around. I guess it doesn't make it harder. You just can't be a giver upper. You have to keep on going. All right. So to start solving, you would subtract 1 and then divide by square root of 3. Good. So -1 over square root of 3. I'm not going to write it on the board. I keep on writing those 2 options on the board behind me. We got to remove the training wheels because it's not going to be up there when you take the test. This would be negative what over what? Good. Perfect. 1/2 over square root of 3 over 2. Because if the 2's cancel, you get 1 over square root of 3. I'm going to let you look at it a second while I answer this question. Go ahead.
know the 1/2 square root of 3 over 2 rule. Is
Okay.
it okay if we just skip straight to
Yeah, if you don't show this, that's fine.
No, I mean, like, if you don't show. Oh, wait, is that what you meant? Like, if you don't show.
Yeah, if you don't show this part, that's okay. Yeah, that's fine. And
2, so I was really confused. I thought it was 2.
oh, no, I'm sorry. That's a 3. We're okay now? Okay, here is how I remember the quadrants for tangent and cotangent. They go across from each other. Since this is negative, we cannot be in quadrant 1. So it's going to have to be 2 and 4. So tangent and cotangent go across from each other. If it's positive, you start out in quadrant 1, you would get 1 and 3. This one's negative, so it's 2 and 4. Cotangent is x over y. So the x is the 1/2 or negative 1/2, whichever one of these you want to label. Y is square root of 3 over 2. So once again, our angle is pi over 3. It's either pi over 3, pi over 4, or pi over 6. So don't be alarmed if you get the same thing several times. There's only so many options, all right? Now, buckle up. This is going to be a little bit of writing. It's going to be 3x equals, and we're going to go around 3 times. So total, how many answers are there going to be? 6. Good, perfect. So the first one, we get 2 pi over 3, and then this one is 5 pi over 3. Now you have to add a rotation, 6/3. Good job. What if it was 6? Then it would be 12/6. Good. Okay. I keep forgetting you guys are fine with fractions. I keep harping on about it because usually it's a problem, but you guys are fine. Basically, just add 6 to each of these numerators. So the next one would be 8/3 and then 11/3. And then one more time. So you're going to add 6/3 to each of these. So what's the next one? Yeah, 14/3 and then 17/3. One more step. Do you remember the one in the notes we did that had 8 answers? I did that on purpose. So if you can do 8, you can definitely do 6. Your last step is to divide by 3. If these are already divided by 3, when you divide by 3 again, they are now close, 9ths. None of them reduce, so you can just mindlessly copy them all over 9ths. Or over 9, I should say. You can do it. It's not hard, it's just a little bit more writing. Yeah, I always bring up the pizza example. Imagine pizza that was cut into thirds, like there were only 3 slices, and then you cut each of those into 3. So now you'd have 9 pieces of pizza. Oh, if they did reduce, I'd like you to reduce them. I probably wouldn't take off for that at that point though, because that's one of those things where like if your answer is right, I'm so overjoyed that I kind of just, do you know what I'm saying? Like you did everything else right. I don't want to ding you for not reducing a fraction, but then at the same time, you should be able to reduce a fraction. So do your best. All right, for this one, we're going to divide by 2. So it's sine squared equals 1/2. And then there's one more step there before you can draw your triangles. What are we going to do? Square root. Now, when you put the square root, you have to put plus and minus, and you just square root the numerator and square root the denominator. So what is the square root of 1? 1. Good job. Don't overthink that. And the square root of 2 is the square root of 2. You don't get a calculator, so that's what that is. And then if you rationalize, oh my gosh, it's square root of 2 over 2. Ain't that crazy? What quadrants are we in? All of them. And good, you're saying the answer already, which is pi over 4. And so you're going to go around and just list out all of your 4th answers, which it ends up being all the odd numbers. So it's 1/4, 3/4, 5/4, 7/4. Whoa. I can hold on. Sometimes you got to just look at it and let it marinate for a second. Like there's not a question there so much as you got to just like look at it and let it sink in.
So when it's a plus or if it's a plus or a minus, we're going to have 4 answers if it's just the X.
Yes, the only times you have to worry about going around the circle extra times is if instead of X, it's 3X, or like this one was a half of X, we only went halfway around. But if it's just X, you don't, which is gonna be most of them. I think I only threw 2 of them on there that weren't just X. All right, when you look at this one, I'm gonna make a sticky note here. You should look at that and kind of think, oh, that looks a lot like this. Do you see the comparison? Okay. Just watch me do this. If we were to factor that, how would we split 4x squared? 2x and 2x, or I guess it could be 4 and 1, but I think this is correct. We'll have to see. And then 1 would just be 1 and 1. And then what symbols would you need? Well, if we have a plus and a minus, they'll cancel, and we have -4 in the middle, so they're both negative. All right. This is going to be the exact same thing, except instead of x, it's what? It's cosine. So it's going to look like this. You'll have your 2 parentheses. Instead of 2x minus 1, it's 2 cosine x minus 1. But you can always do the problem off to the side like this to work it out. It's the same exact thing. Now, why is that extra nice? Why is that a good thing? What do you notice? They're the same. So instead of having to do 2 problems, we only have to do 1. If they were different, you'd have to set this one equal to 0 and then set this one. Remember that? You have to do 2 different problems. Well, this time you only have to do 1 because they came out to the same thing. So that's kind of nice. All right, so what would you do to start solving it? Yeah, I'd move the, so you'd add 1 and then divide by 2. Yeah, you kind of just only need to do 1 of them. So cosine is the x value. This is positive. What quadrants is x positive in? Yeah, 1 and 4. And once again, I can't really fit it in here because this is too small. I'll give you more room on the test. But the 1/2 would go along here, which means this side is square root of 3 over 2. And once again, your angle is pi over 3. I think I did put some on here that are 6 at some point. But you get 2 answers, pi over 3, and then what is the one in the 4th quadrant? Yeah, 5 pi over 3. Let's finish this section and then I'll give you a break. So we'll finish these 3. All right, looking at this one, you have 2 terms. What do they both have in them? So, good. So GCF, we're going to factor out sine of x. You're like undistributing sine of x. So what would be left? Tangent x, good, plus 1. Whose phone is dinging? I don't care. Can you just turn it off? Yeah, just see if it is. All right, so now you do have 2 problems for this one. You have to set this equal to 0, and you have to set this equal to 0. So sine of x equals 0, that just gives you that. What would you do to solve this one in the parentheses? You would subtract the 1. Are we good? This is going to be a circle instead of a triangle. But are you guys good with why this is a -1? Subtract 1. Okay. So you need places, and I'm looking for words like up, down, left, or right, where sine is 0. Sine is the y value. So left and right. Good. 1, 0, and -1, 0. So you get 2 answers from that one. If you're right here, how far did you rotate? Yeah, 0, none. None pi, like no pi for you. And then the one on the left side of the circle is just pi, 1 pi. Now it feels like this one would be a circle too, but it's not, okay? So what quadrants are your triangles in? It's not all, because it's not plus and minus. Remember, they go across from each other. It has to be 2 and 4. It can't be quadrant 1 because it's negative. Okay, so the way that -1 is that both sides are the same. And so this is your pi over 4 triangle. So you get 2 answers. What is your 4th answer that's in the 2nd quadrant? Yeah, good. 3 pi over 4. And then this one would be 7 pi over 4. So total of 4 answers to that. When you factor, oftentimes you get more answers because it's like a problem A and problem B. I was kind of just taking it easy on you with this one. I made them turn out the same so that you only had to do 1 problem. All right, we'll do a couple more and then I'll give you a break. For this one, you would add square root of 3, so it'll be positive, and then divide by 2. I would actually say this is probably one of the easiest ones on there. What quadrants are you in for sine to be positive? First, and one more. Second, good job, like kitty cat ears. Sine is the y value. Again, your angle is pi over 3. So what are your two answers? Good. I feel like that one was easy peasy. That one wasn't. They're not all going to be really hard. Yeah, you get, I mean, like I say all the time, a test is going to be a collection of easy, medium, and difficult problems. All right. For this one, you would add 1, so it's going to be positive, and then divide by square root of 3. So again, I'm not writing the options on the board anymore. You got to remove the training wheels there. You back that up a step, it's going to be 1/2 over square root of 3 over 2. Tangent, cotangent go across from each other. This is positive, bless you. So we want quadrant 1, and so the other one is 3. Cotangent is x over y, so 1/2 is the x, square root of 3 over, gosh, I hope I put a pi over 6 on here somewhere. These all came out to pi over 3 or pi over 4. I mean, those are the only options. So your two answers are pi over 3, and then what is the one for the other? Yeah, that one was actually easy peasy as well. There wasn't too much to that. Now the directions, these ones, they solve for all solutions. That means forever and ever and ever and ever and ever. So you're going to have plus something n. So let's look at this first one. You're going to start out the exact same way though. You would start by doing square root. So the square root of 1 is 1, but you're just going to get plus and minus, which is kind of nice in my opinion, because you don't have to worry about what quadrants you're in. It is simply going to be all of them. I know it feels like it would be a circle, but it's not. It's a triangle. So what are the sides? So you can end up with 1. Square root of 2 over 2. Perfect. And the whole point of this is the angle, which is pi over 4. Now, this is a special circumstance where you can get away with just writing this in one statement. You don't have to break it into 2 separate statements. And don't worry, I'm going to do another one where you can compare and contrast it, okay? We'll do the one right below it so you can kind of compare and contrast these. But the fourths are completely evenly spaced. Do you get what I'm saying? Okay, so the first one is pi over 4. And you only have to go 1/4 of the way around the circle to get to the next one. And then 1/4 of the way again to get to the next one. Like these are all nice and evenly spaced. So it's going to be plus how much n? What is 1/4 of the way around the circle? It is pi over 2n. Good job. So you are going pi over 2 distance to the next answer. Now, hold any questions until I do the next one so you can compare and contrast these, because I think it'll answer itself. For this one, you're going to add 1 and divide by 3. So it's going to look like this, 1/3. Now you have one more step there, which is square root. So we're going to get plus and minus. And remember, you just square root the numerator, square root the denominator. So what is the square root of 1? 1. And the square root of 3 is square root of 3. Without a calculator, you're just going to leave that alone. And again, I don't have it on the board behind me because you got to get used to doing this, but it's going to be 1/2 over square root of 3 over 2. So which quadrants are we in? All of them, because it's plus and minus. And again, I did this on purpose so you can compare and contrast number 25 and number 27. Now, tangent is y over x. So the 1/2 is the y. Oh, good. That means the angle is what? Yeah, I was hoping I at least put 1 on here that was pi over 6. Now, do you get that these are not evenly spaced the way that the fourths are? Okay, so you're going to have to write 2 separate statements for your answers. You can't get it all in one fell swoop because they're not nice and evenly spaced. The fourths are all evenly spaced halfway. They're all like right in the middle. The sixths are not. We don't draw these triangles to scale, but here, I'll attempt. So the fourths are like this. Do you see what I'm saying? They're all right exactly in the middle. I made my best attempt. Those are all like 45 degrees. Do you get what I'm saying? Like these are all 40. We're not doing degrees anymore, but see what I'm saying? All right, now for pi over 6, it's more like this. Do you see what I'm saying? Like this is 30, but then this is 60, and then 60, and then 30, and then 30. Like, do you see how they're all different?
Yeah.
Is that making sense? Okay, since we don't draw them to scale, it's not going to make you get out a protractor or something. All right, so you have to write it as two separate statements. So this first one's pi over 6. Now watch me point to this. You have to go halfway around to get to this one. We're going to do these two together. So we're going to add how much pi to get halfway around? Yeah, 1 pi, so plus pi n. Now do the exact same thing, just repeat the process to get these two. So what is the answer in the second quadrant? It's 6 this time. 5 pi over 6 plus pi n, and that gives you these two. Forever and ever and ever, as many times as you want to go around the circle.
Why end when you can only like?
Halfway around the circle.
6 dollars can be fine.
It could be thirds. If you're going halfway around the circle, it's plus pi n. If you have to go the whole way around the circle, it would be what? 2 pi n. It has to be fourths. It has to be evenly spaced. That's the only time you can do this. This is that special case.
So is the only answer is half pi?
When it's like this.
2 pi?
Yes,
This is the only.
those are the only choices.
So if you can gauge right down one of them.
Mhm.
You said the pi over 4 one, that's the only one.
That's the only one that you can do this with. Yes, exactly. All right, let's try another one. Here you would add 1, so sine of x equals 1. Now that's going to be a circle where, I'm looking for a word like up, down, left, right, is sine 1. Sine is the y value. Up, 0, 1. So that answer is how much rotation to get up to the tippy top? It's pi over 2. Now you have to go the whole way around to land there again. Don't zone out and then ask a million questions. All right, you have to go the whole way around to land there again. So it's going to be plus 2 pi n. All right, one more. You will subtract square root of 3. So it's going to be negative and then divide by 2. So negative square root of 3 over 2. So I need quadrants where cosine is negative and cosine is the x part of the point. So 2 and 3, good job. Now you're going to have to kind of watch me point to this because I can't really fit it in there. It's too small, but this is where the negative square root of 3 over 2 would go. That means this side is a half. Oh, and good. We got another one that was pi over 6. You have to write this as two separate statements because these aren't evenly spaced. I didn't get a plus minus where I had, well, they still wouldn't be evenly spaced even if I had a triangle in every quadrant because it's 6, not fourths. So what is your answer in the second quadrant? 5 pi over 6. Now look it. How far do you have to go to land on that answer again? Yeah, 2 pi, the whole way around. So plus 2 pi n. To land there again, you go the whole way around. And now we're going to do the same thing with this one. What is your answer that's 6 in the third quadrant? So 7 pi over 6. And you have to go the whole way around to land there again. So it's 2 pi n. You can only do plus 1 pi n if they're exactly across the circle. Look it, I'll point to it for you. Do you see how these are exactly across the circle from each other? So you can do half a pi and land there. You don't have an answer that's on the other side there. You have to go the whole way around to get your other answer. But it is either going to be plus pi over 2n, which is for this particular case, plus pi n or plus 2 pi n. Those are the only options. There won't be another choice. It's one of those three.
Just because we don't have enough room on this, I know when I put like 1/2, when I put the conservative.
If you don't put that there, if this side is correct and your angle is correct, I'm good with that. Because I think we've progressed to the point where like that's enough for me. Okay. We'll go through it. So on the test, I made everything, are you listening? I made everything match up exactly. Okay. On here, I made it so that you can use the answers more than once.
Oh my God.
But do you know what you should do on the test, since they all match up exactly, if you come down to 2 questions and 2 answers left over and you don't know which one is which, do you know what you should do? Put the same letter for both of them because you will get at least one of them right. Do you get what I'm saying? Like in theory, if you put A for everything, you would get at least one question right. Please don't do that. Okay. But here we go. What can I replace tangents with? Sine over cosine. Good. So this is going to be negative sine over cosine. And then cosine I'm leaving alone. So I'm just going to put it over 1. The cosines are going to cancel. You get negative sine. So I want you to look through the choices. Which one of those means negative sine? Because it's almost negative sine. B, sine is odd. So this would be negative sine of x. Now I'm still going to mark it off. I think a couple of these do get used twice, but you're not going to use them 3 times or anything. So I'm still going to like check them off. All right. This is your Pythagorean. These are the only ones that I would write off to the side. It's sine squared plus cosine squared equals 1. That's the one that I memorize. And then you can divide through to get the others, or just memorize those as well if you want to. If you divide everything by sine squared, you're going to get 1 plus cotangent squared equals cosecant squared. Yes, or you can remember the cos go together. That's another way. And then if you divide everything by cosine squared, you're going to get tangent squared plus 1 equals secant squared. So tangent and secant are kind of buddies. So if you do secant squared minus 1, if you subtract that 1 over, that is going to equal tangent squared, which good is F as in flamingo. All right. What can you replace secant with? Yeah, 1 over cosine, good. Big fraction bar. And you can replace cosecant with 1 over sine. So if you divide by a fraction, you multiply by the reciprocal. So I'm going to flip that over. So you end up with sine over cosine, which is tangent, which is E. I hear you guys saying the answer right. E is an excellent. Now, this is squared. That means a twin. For the sake of having enough space to write this, what I would do is just scratch out the squared and just write it again. And then we're going to multiply that all together. So sine times sine, sine squared. The outsides would give you minus sine cosine. The insides would give you minus sine cosine. So you would have minus 2 of them. And then the last, a negative times a negative, be positive cosine squared. Now looking through that, I have a sine squared plus cosine squared, which would equal what? 1. So look through your choices and see if you can find it. Yeah, good. L, 1 minus 2 sine, you know, it's going to be matching and you're going to be able to narrow them down. L is in lovely. London. All right, what can you replace cotangent with? Cosine over sine, and then times sine. So the sines are going to cancel. So it's just cosine, C as in cosine. For this one, we're going to distribute through the parentheses. Now, when you multiply sine times cosecant, those are reciprocals, so you just get 1 minus, and then sine times sine is sine squared. When we did sine times cosecant, those are reciprocals, so you just get 1 minus, and then sine times sine is sine squared. Now, if you do 1 minus sine squared, you get cosine squared, which is D as in delightful. All right, looking at number 7. If you do sine squared plus cosine squared, if you combine those, you get 1. So it's 1 plus tangent squared. And 1 plus tangent squared secant squared, which is J as in jump rope. All right, for number 8, what can you replace cosecant with? 1 over sine, good job. Times, I'm going to put a little dot. What can you replace secant with? Yep, 1 over cosine, big fraction bar. And what can you replace cotangent with? Yeah, cosine over sine. Now stop and take a deep breath and look at what you have. The sines are going to cancel. The cosines do not. If you want to think of this as cosine over 1, what you're going to do is multiply by the reciprocal. You would have to flip that over. So instead of canceling, they multiply. And you get 1 over cosine squared, which, look through the choices, 1 over cosine squared would be secant squared. Now, we already used that one, but that's okay. We can use it again. So J is the answer to that one. That's not going to happen on the test, though. I made it so they all match up exactly once. But I always try to make the study guide harder than the test, rather than the other way around. All right. What can I replace this with? 1 over tangent squared. The cotangent squared. I kind of ran into the problem there. Now, both of these terms have a cotangent, so we're going to factor that out. Or actually, no, hold on a second. I don't want to factor. That's going to make it more complicated. Cotangent times tangent. Those are reciprocals, so that would be 1. So cotangent squared plus 1. Do you see how I did that, though? I was going to try and factor, and then I was like, no, wait, that'll be more complicated. Like, if you start to do something that's going to be more complicated, just, make it simpler. So cotangent squared plus 1 is cosecant squared, which is G as in gravy. When you multiply reciprocals, they go to 1. So if you did cosine times secant, that would be 1. If you do tangent times cotangent, that's 1. If you multiply the two reciprocals, you get 1. All right. This one, does this look like a trinomial to you? Could you see it as 4x squared plus x minus 3? Do you see what I'm saying? So you would split it with your 2 parentheses, but listen, work smarter, not harder. You have choices. There's only one choice that looks like you factored this with tangent and a 4 in it. M, as in Mother's Day. All right, so you didn't have to actually do the problems. As M as in money. All right, M as in Miley. What can we replace cotangent with? Good, cosine over sine. What can we replace secant with? 1 over cosine, big fraction bar, and cosecant you can replace 1 over sine. So then you stop and you take a breath and you look at what cancels. The sines are going to cancel. And the cosines also cancel. So the whole thing just equals 1, which is A, as in Ashby.
No,
A is an apple. All right, here's your negatives. The even ones turn positive, the odd ones turn negative. Cosine is even, so that's going to turn positive, just plus cosine. Tangent is odd, so that's going to be negative, negative tangent x. So the tangents cross out, and you're left with just cosine, which is C as in caterpillar. So we did use that one twice, but that's not going to happen on the test. Very hungry caterpillar. All right, cotangent, you can replace with cosine over sine. Tangent, you can replace with sine over cosine. Now, unfortunately, and I would consider this maybe like the first really difficult one we've done, you need a common denominator, which is going to be sine cosine. So this one needs to be multiplied by cosine, and this one needs to be multiplied by sine. If you're able to hold that in your head, that's fine. I just wrote it out because I'm doing the problem in front of a whole group of people. Now, if you mash it all together, cosine times cosine cosine squared plus sine squared. Good. Now hold on, because you're probably like thinking, hopefully, about what that is going to equal. All over your common denominator, which was cosine times sine, or sine times cosine. It doesn't really matter what order you put that in. But what does this numerator equal? 1. So you get 1 over that stuff, and then you reciprocate it. So your reciprocal of cosine is secant. Your reciprocal of sine is cosecant. And so, yes, that is K as in kangaroo.
Yeah, I was thinking.
Hayes and Kelty. All right, what can we replace cotangent with? Yep, cosine over sine. Cosine I'm going to leave alone, so what do I keep suggesting to do? Yeah, put it over 1. And then what can we replace cosecant with? 1 over sine. Does that all cancel? No, it doesn't all cancel. Instead of canceling, they multiply. So you get cosine squared over sine squared. It's going to look like this. Yeah, cosine over sine is cotangent. It's just squared. So N is in nice. I'm going to skip 15 because that is arguably the hardest one on there. You would need to get a common denominator between these two things. When you come across something like that, what I suggest you do is leave it for last, and it's whatever choice you didn't use yet. Do you understand me? That's what I want you to do on the test too. Work smarter, not harder. Now, this is a co-function. This is why I want you to say them correctly. You add or remove a co. So since this is cotangent, if you remove the co, it's going to be tangent, which is E. And whatever one we didn't use yet is number 15. So what did we not use? Yeah, H. I will work that out if you want me to, but I promise that it's the answer, okay?